Okay, so BC is perpendicular to AC, BD is perpendicular to AD, thus making them what kind of angles? Right angles. On a quiz or test, you won't be given the right angles, so you just have to mention that they're right angles by what? Definition of perpendicular line. AC is congruent to AD, and then AB is a what? Shared side. So it's just like the one we just did, only with a little less work. Alright, this one I'm going to put in two-column format. BC is perpendicular to AC. BD is perpendicular to AD. Because it is given. Again, if you want to write all your givens in the beginning, feel free. Alright, I'm going to take those two and come up with my conclusion, which is angles C and D are what kind of angles? Right angles. Again, we're never saying they're congruent. You can add it if you want, but you got to include the right angles. Congruent right angles is great, but the right angles is the priority. Definition of what? Perpendicular. Feel free to abbreviate. AC was congruent to AD because it is given. Number 4, our shared side, which in this case is what? AB, good. I can move it on up, absolutely. You got it. All right. That's going to be enough to say the triangles are congruent, and this is where some of you might want to work backwards. We're going to give a triangle congruency statement. That's going to be followed by what 5-letter statement? CP, CTC, and then followed by definition of angle bisector. So we want to prove that angle CAD is bisected. So that's that angle there. All right? That's that angle there when we do it. So number 5, triangle CAB, congruent to triangle DAB, our new best friend, hypotenuse leg. 6, angle CAB, congruent to angle DAB. Again, you can number those if you'd like. Feel free. That is going to be what 5 letters? CP, CTC. And then number 7, AB, bisects angle CAD, definition of bisector. Definition of bisector. All right. Seem good? All right. We'll come back to that one because that involves adjacent triangles. We'll most likely get to it tomorrow because that'll bring us into our next lesson. Instead, we're going to come down to this one, the circle one. Circle T. What does that give us? What 2 segments? WT and TV, or TV and TW, however you call it. TU is perpendicular to double V, to WV, so they're going to be right angles. And then just like the other 2 proofs today, what do we have right in the middle? A shared side. They give us the hypotenuses. We have a leg with the shared side, so it's going to be what? Hypotenuse leg. So circle T, because it is given. Because remember from earlier in the year, Pythagorean theorem, the side opposite the right angle is your hypotenuse. Number 2, it doesn't touch both sides, so it's got to be hypotenuse leg. And we're going to talk more about it tomorrow on Monday. If it touches both sides, then it's got to be side angle side, not hypotenuse leg.
Not a right angle, and
I'm listening.
if it's not like a right triangle, and
You can't do this yet.
we could just be like that.
It does not exist, cannot be determined. Side angle doesn't exist.
Unless it's the right triangle. Alright?
Alright, so circle T is given. That would tell us that TW is congruent to TV. All radii are congruent. As usual, if you feel more comfortable with definition or property of a circle, feel free. TU is our shared side, so we'll go with that. Then I'm going to go to my second given statement, which is TU, perpendicular to WV, given. All right. Good. Feel free to go back and label these with a what? A 1 and a 2 if you like. Angle 1. Angle 2 are right angles. Again, we're not saying they're congruent. We're saying they're right angles. By definition of what? Perpendicular. And then all they're asking us to prove is triangles are congruent. So triangle TUW is congruent to triangle TUV by hypotenuse leg. By hypotenuse leg. Right. One more and then we'll call it a day. The one on the top of the next column. Alright, so you don't necessarily have to worry about it next week, but later in the year when we deal with properly or quadrilaterals, this is going to be a big deal. What type of figure do they tell us this is? A rectangle. The definition of a rectangle is that it's an equal angular quadrilateral. And all those angles measure how many degrees? 90, which is what we need. So angle C and angle E are going to be right angles by definition of, okay, a rectangle. Awesome. Now, BC is also congruent to what? FE or EF. That's not the definition. That's a property. A rectangle is defined as an equal angular quadrilateral. That is a property of it. If you're confused with that, I doubt this is going to show up. However, if it does, you can just say opposite sides of a rectangle are what? Congruent. Okay, you can say angles of a rectangle are what? Right angles. If you want to just stick with that, you'll be fine. Now, it says angle DBF is congruent to angle DFB, which is great. Here's our problem. Neither of those angles are part of the triangles that already have two things. You agree? But what does that make that triangle in the middle known as BDF? What type of triangle? Isosceles. Because the angles are congruent. And when we went through the other day, beginning on Monday, if the angles are congruent, so are the what? Two sides. So are the two sides, BD and DF. So I'm going to put tick marks on them. And remember, anytime it's not in the given information, the reason is always what? Isosceles triangle property. Not definition, property. At that point, are the two outside triangles congruent? Yep. By what? Hypotenuse, leg. For D to be the midpoint of CE, these two segments have to be what? Congruent. That's going to be your what? CP, CTC. And then finally, we would say D is the midpoint of CE by definition of midpoint. So, rectangle BCDE. Because it is given. Angles C and E are right angles. Angles C and E are right angles. Rectangle definition. Or you just say angles of a rectangle measure 90 degrees. BC is congruent to FE. Rectangle properties. Again, if you don't want to distinguish between the two, I understand. Just write what it is. Just say opposite sides of a rectangle are congruent. Alright? Then they told us that angle DBF is congruent to angle DFB, which was given. We use that to say what two segments were congruent. BD and FD, good. Isosceles triangle property. At that point, the two triangles were congruent, so BCD, with C being the right angle, is congruent to FED by hypotenuse leg. All right. We said that to make D the midpoint, we'd have to say CD is congruent to DE by what 5 magic letters? CP, CTC. And that leaves us with D as the midpoint of CE. Definition of what? Midpoint. So we are on our way. Definition of midpoint. All right? All good? Okay, so again, no homework tonight. Just go back into Google Classroom, please, and check